This is Tim's tip number 2. In my prior video, I showed you my 1.9 kilowatt solar installation as well as my lithium 48 volt pack. In this edition, I'm going to show you the advantages and disadvantages that I found, some lessons learned, so that you don't make the same mistakes that I did. So here we go. One of the positives of the Orion BMS system is that I have an internet connected laptop, and it is connected to a projector that I can easily sit with my mouse and tweak voltages, look at the voltages, and be able to control the maximum and minimum charging as shown on this screen, maximum charge and minimum charge voltages. Also turn charging on and off with the system. I can also see some of my favorite, it's a home entertainment system as well, so it's one laptop that does everything I need. Another positive is that I have allowed enough room on the roof to be able to walk, so I put this marine grade anti-skid compound on, so I have a nice maintenance access panel, access to all the maintenance on top of the roof. In exchange for more room on the roof, I actually extended the solar panels about 6 inches past the roof line. This may be considered a disadvantage if it ever hits a tree. A lesson learned from this is that I would purchase a Victron pure sine wave inverter and charger if I were to do it again. This is a Chinese unit sold by Electric Car Parts Company. It was about $300 to $500 cheaper than the Victron equivalent, and it does the job. However, it is made with inferior components. It was sold as a solar power solar charger, MPPT, and it was not. So there was deception in the specifications. After about 9 months, it's held up okay. It's still doing the job, but I have concerns of long-term supportability, maintenance. If it ever breaks, I basically have to buy a new one, and there's no maintenance on it since it is made in China. Another lesson learned is the thermal management system in the 48 volt pack. This is a picture of the fan that is circulating air from the main cabin to the battery pack. You may say safety wise it's not a good idea, but these cells do not vent unless there's a serious problem with them. And so temperature control, they cannot freeze, nor should they get above, say, 85 degrees Fahrenheit. So this fan helps circulate the air in the cabin, so if we're comfortable, the batteries are comfortable. I tried to design a thermoelectric cooler using CPU coolers that are thermoelectric, so I tried to pump current into them and cool off the battery compartment, and that was unsuccessful. There's a hole that I put in to the battery compartment to vent cold or hot air into the basically another compartment which is vented to the environment. But I would recommend considering a thermal cooling system, maybe active, maybe a small refrigeration system. If possible, one that only draws maybe a couple hundred watts, but gets you the cooling that you need to keep these batteries cool. Another photo I show is to elevate, to keep the cells above the floor, because sometimes the floor gets to freezing because there's just some steel elements in there to the environment that could actually cause some of the cells to get real close to freezing. So I had to elevate the cells, and that would be better to design something up front rather than afterthought like I did. I had to jack the batteries up and put wood blocks underneath them, and as well as a aluminum plate. The last improvement opportunity may be to, instead of going with a 48 volt system, go with a 12 volt system. What you see here is the 12 volt power supply / charger that supplies 12 volts for the coach. The positive of this is that it also is a battery charger for the engine battery, so whenever I start up I have a freshly charged battery, and that charges from the 48 volt system to the pure sine wave inverter to this DLS 90 amp 12 volt supply. So has some positives and some negatives. The 48 volt supply is tough because if it goes down, everything goes down. On the positive side, it uses less wire, much less wire thickness to supply the current that I need. Tops 50 amps versus hundreds and hundreds of amps for a 12-volt system. So I have to think twice about that, but I like the 48 volt in that respect. Also for solar charging, the solar panels are about 78 volts, and then it has to, the MPPT solar charger only has to get the voltage down to 48 to 53 volts for the system. But anyway, the 12-volt system, the 12-volt converter here, does have a load on it continuously, so you're wasting power there. The pure sine wave inverter, to power it, draws about 100 watts minimum. So it's sitting there, whether you're using any power or not, drawing about 100 watts. So that is a downside. I hope you've enjoyed this video, and we'll see you next time. Thank you.